All right. Thank you. Thank you, everyone. So I'm Jais. And so thought said it so well. I'm just not bother you too much. Can all of you hear me properly? All good. So let's start. So I'm going to do the help. It's not the only talk I'm giving today. I'm going two other talks, one on libraries and library management, or one on simulations. But this one is about AI and more specifically about LLMs and VLMs. Just very quickly, do you know what an LLM stands for? Raise your hand if you know what an LLM actually stands for. Not everyone, all right. And then a VLM? All right, perfect. So I'll go a bit through what those actually are before we get a bit more in depth. Super quickly about me. So I'm a builder. I like to build stuff. I'm building wearables most of the time. So they can be for horses, they can be for healthcare, they can be for sports. People. And because of this company, I've basically been doing software as well as hardware. I'm not an electronics engineer by background. At all, everything I learned, I did it by doing. So that's, well, I'm not an expert in electronics. So I know all of you use KiCad in different ways. And what I'm going to show you in all my presentations is what I felt was needed to do. I started AmpereBrain. You will see AmpereBrain is a project manager in a way for KiCad, something that comes on top of KiCad and that can, it's like a plugin, but a bit on steroids because the IPC is not completely ready yet. So I kind of made something that kind of unlock the full, everything you can do with schematics, with libraries, etc., etc. I'll make you a demo, make you several demos later on. Even though this morning without internet, that's going to be a fun one, but we'll see what I can do. Everything I did with AmpereBrain is quite recent. I only started it like 3 months back, so I hope it works. I've tried yesterday all my demonstration. Half of them were working. Well, we'll see how that goes. So what we'll talk about today, I'll put clear boundaries about what kind of AI I'm actually going to talk about. Then we're going to talk about all the challenges related to using those LLMs like ChatGPT into solutions, into electronics design. So there is first the context challenge, the context problem you might have heard about. Things about context engineering, but that's basically what information you're actually giving the LLM in order to solve your problem. Then there is the datasheet challenge. Reading a datasheet, I think machine to read a datasheet is hard. There's no other word because you know how messy a datasheet can be already for us. Then there is the orchestration challenge. The orchestration, it's when you ask, even when you ask a person to do something, it can be challenging if one person does everything. You are specialists, you have this kind of thing. So the orchestration is how do you actually coordinate several agents? That's what that's what they are called in order to do a specific task. And yes, then I'll make a quick demo and we'll talk about what is actually possible in the future. I like to say that I really want to make it interactive. So if you have any question at any point, just raise your hand and hopefully we'll bring you a microphone. I think that's the right way to go, right? Well, all right. So let's start right away. So I'm only going to talk about LLMs and VLMs. LLM, that's called a large language model. That's what is basically powering the full, the ChatGPT revolution. Let's call it that way. That's what, it's this idea that you are going to have a text as an input. Is going to be divided in something called tokens. But roughly, you can approximate this to words, or if it's an image as an input, like a set of pixels. And based on that, is going to predict what is the next most likely output based on that. A vision language model is the same idea, but instead of having only text as input, you also have images. The way the image is divided and everything, it's a bit more complex than pixels, but ultimately it's the same idea. The whole idea of those vision language model, those VLMs, it's for visual understanding. If you put it into a context of electronics design, that would basically mean, in a datasheet, you have a reference circuitry. Well, how do you actually make sense of that? That's where VLM actually is useful compared to the rest of just being text based. So yeah, those are only good at pattern matching and structured data interpretation. I'm skipping a bit to the last line, but they don't have any understanding of what they are doing. They don't build anything that, you know, they just predict what should be happening next, nothing else. That's the biggest limitation with LLMs. So they don't really create anything new. They just repeat what they've learned before. Of course, there is some lack of understanding of reasoning, but that's not really the way they actually work. So, and in order to, that next step where they might actually start to understand, that's what's going to be called world models. World models, that's likely to be the next increment, yeah, in AI, in conversational AI, because it actually, bears its own representation of what, of what you're actually trying to build. On top of that, I'm not going to talk about any type of specific AI, for instance, for auto routing, these kind of things. Now I'm going to talk about, fully new KiCad that also exist, that are primarily AI based. Also, you might have heard there are some MCP servers. I don't want to get too technical, but that's basically a text interface to change something into your design. There are two initiatives out there which are very interesting in their way. I just don't think that going from an IDE like VS Code to edit a schematics is the right way to go. A schematics is, schematic or just electronics design in general is meant to be visual, and it should stay that way. I'm only going to focus on the schematics abilities. Because that's also what I can demo today, but it can also work for the bill of material or for PCB design as well in the same pattern. So, as I mentioned, the three core challenges. We are talking about the context challenge. So the context, as I said, is about understanding what the project actually does. Then we have the datasheet problem. How do you actually make sense of those datasheets that are not structured, very hard to read? And then the orchestration challenge. How can we actually make everything to work together? Because any edit is actually very complex if you look at it if you divide it step by step into what you have to do. So let's dive specifically into them. How do you make an LLM, an AI, to understand what you are building? The first step, that's basically, the big problem is that when you just feed an LLM, your KiCad schematic directly, you just upload your schematics file and you ask, all right, make sense of what I'm actually building. It's extremely hard because, first of all, they don't have the context. They don't know what you're trying to build. If you use any type of op-amp circuitry, you can use it for so many things. By just looking at the circuitry, it's not obvious what it actually does. And of course, if you put it into a context of much, much bigger schematics, you need to provide some kind of information so that it knows what it's actually building. Then it's about the structure of the data. KiCad is using this expression for its file format. It's not LLM friendly. It may be text-based, but there's not a lot of data out there that is actually expression-based, and LLM get lost very, very quickly if you just feed them that type of data. Then information overload. As I said, schematic can be extremely complex. If you feed them the full schematics with all the information, for instance, into schematics, you have, what is the font of my label? What is how is my text justified? This kind of stuff. That's completely irrelevant information if you want to make changes on a sheet, or if you want to make functional changes. And then finally, because those schematics are quite complex, there is also all the extra complexity. If you want to edit, I don't know, decoupling cap onto your IMU, you don't need what's at the other end of the wireless charger. There's no impact on that. So we need to build something that gives hierarchical filtered information. Yes.
the LLM did not have free smart and you can still higher the atmosphere. You will be the lamest of all the best expression. We got it, but
Yes, we could. The thing is that is it actually worth to do? So right now we don't live in a world where LLM models are specialized. Not yet. It's coming as models get better and then, everything. But right now we're using general models. And through general models, yes, they don't have enough training data. So, if it's wobbly, it makes mistakes sometimes. So it's way, way more efficient to just like, all right, take your thing, put it into a YAML. You don't need to make any change, but something of more LLM friendly language, and then it can edit also better. It's also a question of syntax. If you think of, well, yeah, GSM, they've been trained on a lot of data. YAML is a very, I mean, do you know what YAML is? Yes, all right. So it's a very, very simple syntax. So it's, LLM is less likely to screw it up. That's also what it is. Or any type of syntax mistake can be grabbed quite kind of easily. So yes. So what I've tried to implement in AmpereBrain, there are 4 layers that fixes each of the problem. I'm going to go in depth into each of those layers. So first step, to convert those as expression into something more LLM friendly, to be a better understanding, or to make it easier to edit. Then the layer 2, to extract what is actually relevant based on the information or the edit that we actually want to perform. Next step, layer 3, that's to generate another representation of the circuitry that does not have, I'll say useless, but that doesn't have irrelevant information, so that we only focus on the core of the schematics, which fundamentally is connecting pins together, and how everything is connected, etc., etc. And finally, last layer, the additional layer, it's not really the fourth layer, but it's all the extra context information. Like, what are you trying to build? Yes? No, okay, sorry. Thought it was a question. So, how it would be that structured project understanding? What I've built is that something that just passes completely as expression file from the schematics and can convert it to any LLM friendly language. Can be YAML, can be JSON. Just because, right now the Python plugin is not fully ready for schematics. And I think schematics is a bit more interesting to start with for developing. So what the software I'm going to demo later is going to build is actually a full representation. Actually, maybe I can already show you a bit how it works. Up. No, because I don't have internet. True. All right, so I'm going to continue on the presentation now and finish by the demo because I need to set it up. Of course, this part, if you're interested, it's very similar to what you see in Python, or what the Python KiCad plugin is using. So that source code is fully available if you would like to take a look at it. Then we're going to talk about the filtering. How do we actually select the subcircuits into KiCad, so that we only focus on what's interesting? Now I really need to make you the demo. Let me just find a way to put internet, because otherwise there's going to be it's harder to understand. So the idea is that I build the system so that it recognizes subcircuits. So I know that when I design electronics, I put things in rectangles. Subcircuit goes into rectangle. They have a title like, okay, this is the part of the circuit that address, well, let's say the wireless charging, for instance. Everything is encapsulated, so that when the LLM is actually going to say, hey, I need to make an edit on that part, well, it's just going to scan, which part is actually relevant. And I'm forcing the AI, the LLM, to actually request what is necessary to edit. Trying to share my my connection. Let's see if that's gonna work. Especially because I'm Rwami, you probably guessed I'm not German based on the accent and my name probably. So I'm French, I'm coming from Denmark. So let's see. So I'm looking at the software because it's what I built is basically offline, but there is a license check in the beginning and there's an update check and everything. So if there is no internet, it actually does not work. Boom, 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 boom. Still not? Maybe. All right. Yes, I think it's working. Where is the... All right, so that's basically how the software looks. What I told you, it's kind of a project manager. So you have several projects, and in order to group stuff, so that's basically one of my projects I'm working is related to current sources. It's mostly for demonstration, this one. And the whole idea is that if we look at the schematics, which screen is it going to open on? That's always a good question. Of course, the other one. All right, so it's super simple schematics. So here what you can see is that there are two sub-circuits. They kind of do the same. Don't pay attention to what they actually do, but you can see there's a rectangle around. There's a title nearby, above or below, was whatever you want. And then when you're actually going to go, you can actually see that it's divided. You can see that there's division between the two sub-circuits. And that's what the LLM is actually going to use. It's going to have that list available to see, all right, I'm going to edit that part of the sub-circuits, so I want to see the details of that part. And yes, it all goes into an AI copilot. That's the part that actually helps you to design. I'll come back on it later, don't worry. Next step, it's about the circuit architecture. It's about abstracting once more what the circuit is about. It's about making a diagram. One thing that works great, because LLMs have a lot of it, is mermaid diagram. I don't know if you have heard it. It's very simple. It's a very also user-friendly way of coding diagrams. I think I can show you quickly how it looks if you've never seen that. When you chat with ChatGPT and it outputs a diagrams, that's the language it's actually going to use. So for instance, if you have so it's not super pretty, so it's a bit hard to read, but if you have a graph, for instance, like this that describe a little bit your architecture, that's the text that it actually corresponds to. So this is not schematic connection. That's just what I have in my specs, but you can do the same, more complex, with actual components. And that's a very simple way for an LLM to actually understand what they're doing, because when they're like, all right, where is my point A connected? Where's my net A connected? Where does it go, etc., etc. So it's a very simple way of reasoning about where to go next. So that's what I've been implementing. Last one, the extra informations. That's what I just showed you. What are we building? So right now in that software, it creates a template. It's going to edit some specs, some requirements that follow exactly what you are doing. It's also because I think that specs and requirements should be versioned together into whatever electronics you're building. So everything is synchronized with Git, and you don't have to worry at all about these kind of things. In theory, your requirements are in sync, or your specification are always in sync with your schematics. I hope it's always like this, but that's basically the idea. The AI is also here to help you to make sure that it stays that way. So that's it for the context issue, for what information we're actually feeding the LLM when we want to make our edit. Yes, it's a lot of layers, it's quite complex, but it actually works quite well. Next up, the datasheet. Not all of you are experts in LLM, so I'm not going to talk too much about it, but there's no standard in datasheets. The only file format you can find everywhere is PDF. There is no web page usually for datasheets. So, I'm not going to go too much into details, but they can be very long documents, which make it even more challenging, etc. Also, one issue that I realized by doing it is that they also tend to hallucinate. You must have heard about the hallucination problem. But LLM have been trained on datasheet. You can see that. You can ask a component, how big it is and stuff like this. It can actually answer you. So it's been trained on that data, which also make it like when you ask a question where it doesn't know the answer, it's going to hallucinate. It's going to tell you that, oh yes, based on the other datasheet that I've actually read, I've been trained on, I think the answer is that. But it doesn't say, I think. It's going to tell you with to assert you that it has this value. And that's also a big problem. So when we do any question related to datasheet, that's a real issue. Yes, so I think that's the datasheet issue. I'm going to speed up a little bit. So the solutions right now, it's only been like 3 months, 2-3 months that we actually have models, OCR model, optical character recognition model, but it's LLM plus VLM. Anyway, it's quite complex models that can actually parse a datasheet with making sense, I would say. With that, something that actually, when you look at what's been parsed, you're like, yes, that's my datasheet. It's an extremely recent advancement. I only know 2 models that can actually, that pass my datasheets properly. So it's, it's an early field, and that's kind of, that's the next challenge I'm going to take. Right now, I don't have that proper passing into what I showed you, and that's going to be one of the main challenges that I'm going to address soon. And finally, we need to be able to recognize things like, all right, this is my reference circuitry. You cannot pass this into text. It's too complex. And that's where VLM, vision large model, actually comes in. You're going to feed that into the VLM, and it's going to translate it into, you can ask it a number diagram or whatever use case you're actually using it directly, and it can output you how everything actually is connected. So the goal is really to transform any datasheet into something that makes sense, into something that's structured, and then where you can ask a question and get the right answer from your datasheet, which, what the way it's going to be implemented before you just randomly ask is going to show you where in the datasheet you have the answer. Because, don't trust ChatGPT, don't trust LLMs. That's the basic principle. You need to make sure that what you are seeing is actually true. So that's how it's going to be built. Next step, the orchestration problem. How do we make everything to work together? Let's take an example. Okay, I want to add a new component. What are the steps that you actually take when you add a component on your sheet? You need to answer the question where you actually put it. And that's, physical, logical. Some people really enjoy having like input to outputs into their sheets. Some others don't. And then, it's quite a lot of implicit rules that are not that easy to follow. Then, of course, how to connect it. And how to connect it, there's 2 levels. It's, of course, netwise. But it's also, okay, do I connect it to my other components with wires, with labels? So, that's the next question. Also, do you need any supporting components like a decoupling capacitor? Also, do you have any extra requirements where any engineer would basically make a note saying that, hey, I need that crazy capacitor for my design. Please don't forget it when you do the BOM. That's a good way to screw up a design. So and finally, what I mentioned about documentation, making sure that does it align with your specs, or do I need to update it, or what action do we actually take here? So it's a lot of steps just to add a component, and we can't really provide it all at once. We need to do it step by step, and you can't really ask a raw edit of your schematics to do that. You need to use what is called tools. For instance, like, hey, add my component here. I connect this nets to this one, etc., etc. So that's a bit how you need to divide it. That kind of workflow, that's what we call an agentic workflow. It's several agents that are going to work together in order to ask whatever you're asking. That is adding a component in that case. Strategies about that is quite technical, especially if you're not into AI, but you can relate to how, it's basically how it works in an organization. It's 3 different ways of working. The first one was called the react, think, act, observe, basically asking one guy, one LLM, has all the tools, it can do absolutely everything on its own, and then it's going to be like, oh, right, I've done that, what should I be doing next, etc., etc. You can ask some kind of to-do management to make sure that it does things as you expected. It's not the most reliable one. It works still. The problem is that, as I mentioned before, it's all about the context. If you have one system like this, what's called the context usually becomes very big. That is, first you have the initial information, and then every time it does something, it's going to keep the full input, output, etc., etc. So there's this issue of losing information. I'm not bothering you what's called the context length into LLMs, but you might have heard that also, and it's a very interesting concept. And when editing schematics, we do hit that limit extremely fast. Next up, we have the hierarchical orchestrator. You have a manager that says, okay, you are good at doing this, so you're going to do this part. Then you're good at making calculations, you're going to do that part. And then you basically take up the information and ask, all right, I've done that, so next step is going to be, well, this is successful. I've calculated that I need it in order to make my filter. I need a 20K resistor and I don't know, 3 pico capacitor, and then all right, I've done that. Now I'm going to add that as my supporting components, etc., etc. It's not the de facto standard, but almost nowadays with agentic workflows. It's very good for complex tasks because, as I said, you only get the results of whatever has been happening for each of the tools. So you keep the overall information of what's happening quite short. And then you have something more recent that is called a swarm. A swarm is basically a self-managing team. You have a circuit designer, you have someone that knows everything about electronics, and you're like, every time something new pops up, whoever is either talking right now is going to be like, all right, I need information from 1, from 2, from 3 of those other agents, and then you're going to run it, then gather the information, and then each of these agents, like, okay, what should be the next step, everything. So it's way more chaotic. There's a lot of repetition. That's the problem. It can also give it's usually better in terms of result, but you have way less control. So it's kind of it's kind of a how's it called? Sorry, a trade-off between the different solutions, and more importantly, it's a field that's changing extremely fast. This is a screenshot. Next year, I wouldn't present the same thing at all. I'm sure it will have evolved a lot. I just presented today what is purely schematics design. Not everything is to be that complicated. That's of course the most challenging part, and I was really to give you an overview how complex electronics engineering is. That's electrical engineering is a field on its own, and just doing a schematics is never straightforward. So that's just to give you a little bit of a taste of how things are. There are more straightforward use case of AI. I think one of the most interesting one. Sorry, I'm just checking. Does that work? Yes, it works. One thing that I think is extremely convenient is intelligent commit messages. I'm curious, how many actually have used Git onto their electronics project? All right, how many are using it in all the schematics or production? Okay, about half. Interesting. So what I've did, because I realized that talk to my people working with me, I see this kind of as a burden. They're like, it's hard to make a commit. You need to explain what has been happening. You also need to do it, to remember to do it, etc., etc. So I've basically put something that look at the different version of the schematics and be like, all right, since last time you committed, those have been the changes, and I'm going to show you right after. Those are the changes, and you don't have to think about it. You just get committed, it gets pushed on your repository, and you're basically done. Let me just show you if I can find my mouse on the side. All right, so for us, this is not a very interesting part. Still not a very interesting part. Yeah, well, I think that's, once again, this is an example. So the changes are not very meaningful, but for instance, you can see how the commit message actually gets generated. So on my, my measurement subsheets, there has been those functional changes. So I've added a new component. I've changed the value of one resistor to simple. I probably did something for the simulation. There's been also some changes, on what was included and excluded into the simulation, and a bit on the local symbol library. and it's going to do that for everything. So every time you make a change, it's actually going to parse it automatically. Also work for your KiCad project settings. Yeah, so that's part of what actually is, because I mean, I don't think making commit is something valuable use of time for engineers. So that's one thing that, you know, is going to look at the different version, going to be like, all right, when it passes everything, like, all right, I compare before, after, that's the changes, and then I put a specific template, follow the template, and then it's just going to format it and then commit this. Yes.
The capability AI could make these changes, because I know that they're running where there's regulation where you sort of also store the prompt at the game.
So in which sorry, in which 7 yes. Mm-hmm. Yeah.
The prompt that may change.
I mean, the prompt is part of the software, obviously. So it is, you know, it's you know, it's directly part of the software. So by the way, all of this is purely local. It might not be obvious, but everything here is running locally. The LLM calls right now, they're not that they can be running on a local machine, but to generate commit message, that's definitely possible. But you know, if you want to actually make schematic understanding and everything, you need something that's really powerful. Something that runs locally is not likely to be powerful enough. But yeah, this is really local. The template point is not that crazy when it comes to this part. Does that answer your question? Or I'm sorry, I'm not sure. I'm not sure I got it. Are you talking for legal reasons, or in which aspects are you talking about?
That's that one. Is a project the commit as
How to okay in that way? But I mean, the that's a good question. Do you want to see how the prompt actually works, or what's behind the scene on that part? Because it's not that I mean, it's you know, it's quite simple. There is a template prompt. I can try to run it. Let me just exit this one second. Oh, sorry. By the way, before we go, I just want to mention something in the presentation. No, not that slide. Why did it start again? If you have any feedback, any suggestion or anything, you can go to AmpereBrain.com/feedback. It's a special Kicon form. I mean, it's just something simple. So, you know, if you are shy, or if you have any ideas, if you have any crazy question or anything, just, you know, you can post it there. I'll take a look and I'll answer you. Yes. Sorry again.
what we make is passing the expression files on diskette without interaction with the AI.
Yes. Yes. I'm not using the API at all. So there's basically no KiCad software involvement into what you're seeing. So it's fully standalone. The biggest drawback is, you know, version compatibility is not guaranteed. That's, you know, I need to make sure that it passes everything. Okay, let's go ahead.
I think that for software would be like with the three markers that were so test exactly what shapes is better best derivatives change better than what and this what I think street all or so
Yes. Yeah. Yes.
so Spaß nur why that We are first.
Yes, stop. I show you. I want. Yes, I put something like this. Yes, for instance, if you click here, submit page, you can actually see the where are my changes. All right, great. I can't see them. I don't know where it was added, but there's actually that's not the best schematics I know to put changes. Can see there's been some changes because it's green and red, but I've put something quickly like this to visually diff the change if you want to see. But that's an interesting comment. I mean, once again, it's only been 3 months I'm working on that, so it's super interesting. It's just that it's true in my company. I honestly I didn't even think about that, but it's because because we're a small company and we know why we're making the changes. I mean, I'm basically the one reviewing everything, requesting the changes, so I can afford to see it in the saying that what I've requested is actually done. So, but that's a very good point. Yes.
In that every sheet, every schematic, and every component is now a prompt projection service.
No. Why do you want to I mean, in which way? Sorry, I'm not sure I got it.
I need to be careful what is in my date sheets because they may inject prompts into the system.
Yes, but what can you actually ingest? And that's the question also safety, is that it's tools are quite limited into what they can do. It's not I mean, and that's also the question. Schematics, you will always, it's not like code, you're always going to review what actually happened. There's no, well, but it's a good plan, but I agree, but that's what the Git messages then tells you what actually happened, and that cannot be prompt injected. Oh, I mean, it's very, very complex engineering. Yes, but I mean, once again, it all comes to the abstract of information. We are never feeding a full expression file into the LLM. So
Even the fact some Microsoft structure where somebody in a prompt injection going summarize this and don't put it in the logs, and that worked. And I don't see why this won't work here.
because of the fact that we always synthesize the information before putting it in. Also realize this doesn't have internet access. Also, so it cannot send anything back. It cannot do this kind of stuff. That's one thing. It can damage your schematics, but it cannot have any further changes than this. That's one thing. Safety wise, it's not, nothing can be critical out of those prompt injection attack. But I don't know. That's interesting.
Is critical now.
Yes, but to give you an idea, everything is Git committed, and that's why Git comes in. The LLM cannot run an option like, Git erase my history. Hopefully, it doesn't have that power, and that's what it is. I mean, it's all about safety. It's safety first. You can always roll back, and don't forget, KiCad also has backup mechanism. So between a Git backup, a KiCad backup, that's a lot of backups before everything gets destroyed. Yes. Oh, sorry. Oh, sorry. You wanted to do. Oh, no, sorry. Yeah. Yes. I didn't vectorize. As I said, I think OCR models works, direct textual search. I'm still working on that, so I cannot really tell you much about that, but you store them locally and together with your project or your libraries. I mean, depending on, yeah, I think actually both, if I'm not mistaken, if it's already in your library. The idea is that you can, if I can find my mouse, always. Yeah, it's stored locally, so if you actually click on it, it basically is going to open right away, so that you don't have to spend time looking for it. So that's that's the thing, and then it's stored by the markdown file at the moment, so that you can search it. I'm not going to demo it today because the result I had with my very basic parsing is crap. So yeah. Yes. 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 It's markdown plus pictures. I'm not doing everything that can be converted to markdown will be markdown, and what can be converted to markdown stays as images. And what I will do soon is like, if you realize that, all right, figure 17, a reference design. Okay, I need to build my reference design. Then I'm going to take my pictures corresponding to my reference design and feed it into another VLM. That's the orchestration flow. Yeah. Yes. I will always recommend you to use something open source and you can host locally. I'm not using it right now because, the point is I'm not doing enterprise grade thing with that demonstration. That's a demo, it's a proof of concept. So, but that's the thing, it's possible. It's definitely possible. And I would say, if you are serious about this, buy your own infrastructure, deploy your own model so that you have full control on it. I always recommend that for sure. Mm-hmm. Yeah. Sorry. Yeah, maybe, yes. But depends what you want. I mean, it's once again the advantage of agentic workflows that typically you can use less powerful LLMs. But that's what I was telling you. Right now, what I'm doing I'm trying to remember the orchestration model. The manager is a very light model. It doesn't really matter you need something good, but not something that good. Then I have some expert LLMs when that actually try to understand your schematics. And maybe let me show you a little bit what it can do. And here you need something that's understand what's happening. So if you remember, that's the schematics. I'm not going to show you. So it is basically two current sources, two Holland current sources applied made in different ways. And if you play the game of finding the window, that's the no, sorry, yes, it is that. No, I'm sorry, I was asking a question the other day. Why is it? Yeah, I think something like this. Yeah, I was playing a bit around, but I was basically, how do I actually did the current going through my windows? Yes, I didn't write that well, but you can see that there's a lot of steps toward this, and ultimately the answer maybe was not perfect, but it was definitely most of the ways it was suggesting was actually working. So it recognized that. It basically said that indeed there are two structurally identical implementation of the Holland current source, etc., etc. If you want to, let me check where it is. Editing the voltage. So I will make it a bit bigger, maybe. Yes. You can obviously change the voltage reference that's being used to voltage difference. What is it to change one of the sensing resistance on one side, etc., etc. It's still not perfect. That's a work in progress. Once again, this is not battle tested. This is not production ready things. It's things to develop, and that's also what I want to invite you to. If you are interested to test it out, if you have some side project that you want, open source project where you actually want to try it, you can go on AmpereBrain.com and just sign up to be a tester. You're more than welcome to do that. Yes, also. Deal with what language behavior?
She's that against storms has services sort of from the AI and that's the best practice. I say to everyone.
Where people forget how to do schematics even when AI is ready. I would say there's still a few years before it's anyway good enough to fully. We cannot vibe electronics design yet. It's just not ready yet. So we still need to understand also the best practices. I would love to hear from you, from each of you. What are your best practices when it comes down to that? For me, it's everyone has their own, and I think it's we can ask the LLM to follow whatever works in your company or in the settings you're using. But I know it is quite specific how to do. This thing actually has a memory, so if you actually tell it, hey, what what practices I can think of. But yeah, I want my inputs on the left. I want my outputs on the right. Please make everything like this. It will remember it and it will try to apply it. Will it? That's a very different question, but that's how it is going to move forward.
Yeah. Hallucination, the whole shit, which they are doing. I don't see how it's reproduced for got nice plastic. To use some kind of way.
That's no, no, because there is no benchmark today for electronics design in AI, and then we need something like this to see if that works. That's why I've put so much emphasis on using toolings and no direct edition or everything. The more we use tools, the less likely it is going to mess up, and also the more likely you can actually, you or even an LM can spot a mistake when it actually happens. So I think that's the right way of going forward. But once again, I'm more on the conservative side of I like things to work always the first time. But I can tell you that blue workflow take a long time already because it's a lot of calls, it's a lot of things like this. So there's some trade-off here that are not amazing. So yeah. Yes.
I think like a lot of value stores actually just for circuits. So actually, if you were to take the L1 out, because that's like the most fragile part of this, and have this output available to GMs, wouldn't that actually have more value? Because right now, people checking
And I tend to agree with you. I don't, of course, it depends what you want to do. So I'm not going to, I think there's some, for instance, I talked a lot about the reference circuitry. When you have a reference circuitry, and it's there, you will check it anyway after it's done. So you can ask the LLM to just okay, just reproduce that circuitry, and then, I'll check it later on. When it's fine edits and everything, I tend to agree with you that checking the reasoning is important. The problem is that those reasoning are so long. If you want to read the full output of that, it's just like thinking models. Thinking models are a lot about rubber duck debugging, like repeating themselves another way about, okay, the user asked me to do this and everything. If you start to dig into this, it's a lengthy process. So it's a complex question. It's a genuinely complex question. Once again, here you have access to the all thoughts of everything that was output and everything. I don't think it's very pretty to look at it. It mention what was done, etc., etc. So yeah, I don't know. And honestly, I welcome your feedback if you have any ideas of what is the most valuable ways to use it. So I really don't know today.
big process side. So that's the law.
In which way? In which way? So you mean so? Oh yes. Mm-hmm.
Start with the designer's first zero. So you are missing a copy, which is input by Darbet. This is my thinking process, and this is my result. And then you can use your result.
Yeah, that's true. The thing, aiding too. To be honest, today, if I don't know if you have used ChatGPT and similar things for electronics design, that's kind of what it's quite good at. It's like, okay, I want to design I don't know what you want to design, but I want to do that, to do this. I know that, in my company, we have a prompt that, puts you as a super, or not a super, but an experience engineer that follow the best practices that we usually do. And like, all right, so, what do you suggest we actually address it? And then that's good. And then, that's the, I think that's the first step. Here we're indeed talking about the next level, about can we actually automate it? Truth is that today is challenging. That's for sure. Once again, I mentioned the specification, the requirements. I noticed that LLMs have a great tendency to be like, wait, I don't understand what you're feeding me. Well, I don't understand your requirement. I didn't really see the link between, it doesn't really see the link between the schematics and the specifications. And that's kind of a problem. Today, that's kind of a problem to link those two.
Such scenario, before they built so design their decision extraordinary in a mid-size where it's still young gap between the Roosevelt particular desire. That's how it officially goes.
Me? My question, yes? Yes.
Cool. Cool. So this third sort of list of alcohol.
That's
Mm-hmm.
So, yes. All. Just those bits that I was for.
No, there's no training at all involved. This is just using an LLM out of the box. That's using an API directly and just feeding whatever you have. So there is no really, training or anything. I completely agree with your point. For component research would be amazing. I honestly have no clue how it could be done. I can think of some ideas. I know that it's it's gonna be a fun game. I know that all the how they call the path distributors or the path librarian. So I'm trying to remember the exact name, but the one who actually hold all that path knowledge would be very interesting. Of course, to have all that data sheet and be able to search directly into them. That's a lot of data, and I think that's for leisure because that's a real big challenge. I agree that AI would be great, but yeah, maybe I can quickly show you the what I was thinking of doing next into this. I think I've been taking quite a lot of the time already. So, as I said, I'm going to work a bit on the data sheet. Another thing is about something simple. I told you about the data sheets, but having the footprints I know that you usually check your footprints before manufacturing, just having, okay, what's my KiCad footprint? What's the datasheet footprint? Do they actually match? Because I think that's a very simple check to do. And searching for that in the datasheet is definitely not valuable time. Then going into simulations, because I'll talk more about it this afternoon anyway. But for finding spice model quickly, I didn't show you by the way, but already in the data sheet, I'm very sorry for that. When you have, I don't know if it's in the library, yes, you have a search button for datasheet so that you don't have to search a datasheet manually when you just add a part in a library, or if it's not in your schematics already, you can just press search and it's going to launch an Google search powered by an LLM to just make sure that you have the right PDF datasheet together with your symbol. That's just a side thing. So I want to do also something similar for spice models so that you can quickly simulate something. And also simulation creation on capabilities, because I'm not fluent in spice. I don't like spice, but I have to do it sometime. So that's also what I was planning on building. And then only in more than 6 months, we'll actually talk about real schematics editing, because that's very complex workflow to do. And maybe go into the BOM after that, go into stock management, substitutions. And I think that's actually, probably I would start with substitution rather than suggesting when we talk about supply chain management. But I mean, I don't know. It's give me your feedback or review. I gave you the link to AmpereBrain.com, that feedback. Please go ahead, because right now I've only built it with what I felt in my very small company, what that was actually helpful. So that's basically it. I think I don't know if I still have some time. I don't know. I'm a bit, okay. All right. I need 2 steps. Okay. Yes, I stop. I'm 8 minutes over. All right, then I'll definitely stop here. And we can have a chat. Thank you very